Hello and welcome to this Cloud Foundry Summit session. What I'll be talking about is how IBM is trying to migrate our BOSH Cloud Foundry environment from BOSH and virtual machines to Kubernetes, and we'll show how we're using KubeCF and CF operator to do that. So when we look at this, one of the things to think about is what is our starting point that we're trying to work from. So what we're trying to accomplish is to start from our existing Cloud Foundry system that's been around since 2014, previously branded as Bluemix. And that's a very successful system for us. It's been millions of users and applications over the years. It's global. We federate multiple regions together. We have SLAs of 99.99% and above for multi-region, and we've been achieving those for years now, which we're proud of. But of course, that means that it's a lot that we have to try to maintain and migrate. These existing systems are fully based on BOSH, and they use the IBM Cloud Classic virtual machine layer for the infrastructure underneath that. Now we're trying to migrate all of that to IBM Cloud's virtual VPC infrastructure, the new capabilities that we have in IBM Cloud there, and that means a completely new infrastructure layer. And then we're trying to make sure that we are trying to replace virtual machines with Kubernetes, and we're trying to replace BOSH with Kubernetes. So a lot to do, and we're going to do this with KubeCF and CF operator, and I'm going to talk to you about how. So first of all, just a little bit about those two projects. There's two incubation projects in the Cloud Foundry open source community. So we've got KubeCF, which is, there's lots to it, but essentially it gives us the replacement for the virtual machine and BOSH packaging layer. So it moves us to container images ready for Kubernetes. And then in combination with the CF operator, so this is layered on top of Kubernetes as CRDs, custom resource definitions, that gives us the ability to manage the KubeCF layer. And so that whole system is is taking care of looking at all of the deployment configurations and making that real on a Kubernetes platform. So those are those two projects. What we did initially was we took that KubeCF and CF operator projects, and we said, okay, well, let's see if we can get one of our existing systems up and running on this. So we took one of our test staging environments, and we took copies of the data layers. So that means, of course, we copied CCDB, UAADB, Diego, Locket, and also the droplets. So we took the whole blob store as well, and copied all of those. And then we stood up a KubeCF system and configured it to point to those data copies. And we were really successful. It was great. The system came online, and we saw successful startup of all the applications, as you'd expect, because Diego, BBS saw those applications, and it was able to pull the droplets from the blob store and stand all the applications up and get them running. That was great. However, it posed a lot of questions to us, right? First of all, that was very disruptive, right? It took a downtime of that system to take the original system offline and then bring the new system back up again. And especially at the scales that we have, it take a long time for a BBS and Diego to work through, such a large number of applications and bring them back online. It wasn't incremental, right? So there's a cost issue because you literally have to stand up a second environment that's the same size as your original environment. So you're incurring double costs until you've completely shut one down and got the other one back up and running. And perhaps like the biggest issue of all, beyond the obvious disruption one, was just the risk, right? We don't know for sure that the scale that we are at, that we would successfully bring up the KubeCF side. There's no incremental approach here. So as we thought about this, we thought, this is good, but we've got to think further. The other thing we were looking at is, related to this is scale overall. So we were thinking about how, we have such large environments across multiple geographies and cities, data centers, availability zones, that putting that, at least large amounts of that into single clusters like KubeCF was originally, would be very problematic for us. We don't think that we could necessarily get that amount of scale from a Kubernetes cluster, and even if we could, the logistics of managing it in a single cluster were not appealing, right? I mean, even on the BOSH side, we split our environments into multiple deployments, so we have like separate BOSH deployments for different availability zones, shards of cells. So we wanted to make sure that we could have multi-clustering to do this. So the community work was done around KubeCF to enhance this with multi-cluster capability. So for example, you can split the control plane component tree, so basically everything that's not a cell, from the Diego cells, and run those in a separate cluster. And that work was done, and it's successful, so we're able to build upon that. And there's quite a lot of challenges in that, like networking becomes more complex, and we've done some work on top of what's been done already in there to figure out more dynamic addressability and service discovery. So I'll talk a little bit later about some DNS work, especially that we've done to allow multiple clusters to talk to one another, and in fact beyond that. The other thing, as well as the scale, is back on the limitations of the Big Bang approach. We needed to think about, ultimately we've got to do something which is zero downtime and zero, or as close to zero as possible, risk, right? And so we're literally talking about the metaphor is that it'd be like changing the car tires during a race. With no risk or limited risk. So what it means is, we need to find a way to be non-disruptive, incremental, and reversible in this. And so we created this thing that we call the hybrid. That's what I'm going to spend the rest of my time really sort of focusing on and describing to you, is how did we do this hybrid? What does that mean, and what is it? So first of all, it is a coexistence and basically a federation of both a BOSH system and a KubeCF system working together, right? Because a Big Bang is basically 0% KubeCF and 100% BOSH, and then suddenly it flips over to 100% KubeCF and 0% BOSH. With this hybrid approach, what it allows us to do is to start blending the two together, and it allows us to do an incremental approach on that. That we could even reverse, so we could go from 90% or 100% BOSH initially to 90%, and then 10% KubeCF, and eventually move that to 50-50, and then 10-90, and eventually 0 to 100% split back on the other side with KubeCF taking over, and being able to go back, right? So if we encounter any problems, maybe we hit some scale issues or sort of operational issues that are not as expected, then we can dial that percentage back again. So the way that we, the real critical piece of this design, as we thought about, was that instead of trying to think of things like how to split the data and maybe move some applications to one side with a different CCDP or something like that, we thought, no, we can have a federated overall aggregated system and let Diego, right, do the scheduling. So what we are aiming to have is a federated system where Diego has got cells on the BOSH side and cells on the KubeCF side, and it can schedule to each of them. And so as we naturally decrease the number of cells on the BOSH side and increment them on the KubeCF side, the scheduler will just replace the applications. New auctions will favor the distribution simply of the cells. And it's great because it becomes a much cleaner way to do migration, and in an incremental, reversible fashion. So let me show a diagram that tries to convey this. So yeah, it's quite a busy diagram. I simplified it a fair amount, but there's still quite a lot to unpack here. So let me see if I can describe it. So on the left, you've got the BOSH environment, so I frame that in blue, and on the right you've got the KubeCF environment, and the hybrid is the overall combination of all of this working together. So let's look a bit more. So on the left, you've got these three vertical availability zones that I've got with a red border around them. So that just shows you that in our BOSH systems, we do use multi-data center, 3 AZs, and we split a third of everything into each of them. So a third of the cell footprints in each zone, a third of the CAPI API nodes, a third of the UAA, etc. And then we've got an external database at the lower of the diagram. So we use Postgres clustering outside of BOSH, but it's network addressed from those BOSH VMs on the left. And on the right-hand side, you've got the KubeCF system, where instead of having quite the same availability zones, you still have the concept of zones, right? So in the top of the KubeCF side, I've got the control plane. So you've got all the non-cell components, and we're looking at probably having those in a single cluster, but even within that cluster, there will be AZs and different regionals and data center splits as to where each node is. But so there's somewhat of a mapping, right, as you see from the left side to the right side. And the other thing is on this diagram, and I hope it was clear, is I've shown basically a mid-migration picture here, which is why you've got like bits and pieces of the control plane on the left and bits and pieces of it on the right. So that's the other thing. Not only are we looking to do incremental on the data plane and with the cells, like I talked about before with Diego, but we also want to manage each of the control plane components in the same way. Right, we don't want a big bang take, we have large clusters, right? We have lots and lots of nodes, right? Our Doppler footprint is huge, for example, and we don't want to just like turn them all off on one side and turn them on the other and incur outages of the API and control plane components either. So again, we want to do like incremental things where we start to reduce the number of nodes of each type on the left and increase the number of nodes on the right. And so this picture is trying to show that like midway through doing this is what it might look like, where some of the nodes are still on the BOSH side, and some of them have also been positioned into the KubeCF side, and in some cases maybe they've gone completely from the BOSH side, and eventually, of course, they'll all have gone from there. In addition to those kind of left and right descriptions of the BOSH and KubeCF that I've just given, there's some critical capabilities to make all this work, right? So first, one of them is the network in the middle. So the network, it requires VPN tunnels, it requires a lot of Calico configuration to be able to talk across these infrastructures, and also firewall configurations. Even between clusters on the KubeCF side, a lot of Calico work we have to do to make that happen. The second thing I want to stress here is that, and this is kind of almost like the secret sauce of what we've done so far, is we've built a federated DNS solution or a merged DNS solution, and that's really the magic that allows the KubeCF and the BOSH-CF systems, the BOSH and the KubeCF systems, to work together as one, because it is the place where the unification happens. So that merged DNS at the top is actually talking to the DNS of both sides. So the BOSH DNS and BOSH side, and they call it BOSH DNS as well. On the KubeCF side, it's talking to both of them and federating the results together. So for example, if a cell looks up, let's say bbs.service.cf.internal as a name, that merged DNS result will reply back with the IP addresses of wherever we have BBS running at the time. So if we've got nodes on both sides, you'll get IPs from both sides. If we've moved fully to KubeCF, you'd only get KubeCF IPs. And so it's DNS where everything's coming together, and it's the one place that kind of knows about both sides, and that's how the system works, is because the discovery is all done through there. There's a lot of detail in that, but that's the magic, and it's where we have invested a lot of work, and it's still ongoing to do that. Okay, so let me wrap up by just kind of thinking a little bit about some final thoughts on operations, right? So KubeCF pretty much mimics BOSH, so that's great. We can take the BOSH approach and we can do things that are similar to the manifest, but it's not the same, right? It's a facade that's the same, but you get onto it, there's quite a lot of detail, so that's already a learning curve. But where we really see the big differences is in runtime, right? Because the operations at runtime require you to know the whole Kubernetes stack, CF operator, KubeCF. There's a lot of things replaced, right? No BOSH, you've got Helm, you've got no Monet, you've got probes and health checks, lots of stuff changing. But we think that we will come out of it eventually with a benefit. We think Kubernetes as a technology will be a better layer to run directly onto. And we also have synergies with other IBM Cloud services that run on Kubernetes, and the efficiencies of operations that will give. So, a long way to go. We're still prototyping and working through this, but I enjoyed sharing that with you today. Thank you. So I have a question from Andy Hunt about the merged DNS that we did and whether we've written about that anywhere. So Not in a significant amount of detail, no, but I think we could easily enough do that. It's not especially complex, really. It's just taking it's a component that has a connectivity to both the BOSH system and the KubeCF system, and it is basically just recursing results from both and merging the results set together. So it's pretty much just a vanilla core DNS with a configuration to accomplish that. Yeah, let me know if you have any more detailed question about that. So the other question I see here is the question about the data integration. So for the data integration, we didn't change or touch the data itself in any way. All we're doing is just putting connectivity in place. So, our BOSH VMs can connect to our Postgres databases for, Diego database, UAA, DB, CCDB, Locket. And then we just set up so that the KubeCF pods can connect to the same databases. So they have the same configuration with the same Postgres URLs and credentials, and that's all it is. It's not anything other than just giving the same database access to both the KubeCF system and the BOSH system. So I see another question. How do we bring in the services marketplace? So we think that just, the CF services is just going to come along with it. So it's the same CCDB that's being used. So we still have all of our service broker definitions, services, instances, all of that marketplace will come along. Specifically for IBM, we kind of went away from the CF marketplace in favor of a more generic service catalog in IBM Cloud, but the CF marketplace still does exist, and you can still do Cloud Foundry service bindings, and we expect to continue that with KubeCF. See any other questions? So Jochen Damzog, you asked about whether the customer will have a choice on which side they run. So we don't expect so. The goal here would be that it would be seamless, and also the goal is that we eventually migrate the whole thing over. Partly just from a go-to-market point of view, we don't see a reason to want to offer that, and it kind of works counter to what we're trying to do if people are being able to stop the migration. But from a technical point of view, it's kind of the same, right? What we've done is we've just got one big Diego system, and it doesn't have any identifiers to. I mean, we could do something, maybe overlay something like isolation segments or something to try to control it. But the way it is at the moment is that everything's just an application, an LRP from Diego's point of view, and it can just schedule it over onto any cell. So with the cells on the KubeCF side, or if the cells on the BOSH original side, Diego doesn't know or care. It's just saying, hey, I've got this many cells and this many apps, and I need to schedule and distribute them. So just from a Diego point of view, we haven't considered even trying to put such a control layer in either. We want Diego to just treat it all as one big set of cells and just honor our AZ definitions and nothing more. Let's see, any other questions? So I think we're up on time in the Q&A. I'd be very happy to hear directly from anyone who's got any other questions. There's obviously the Cloud Foundry community Slack. We're in there. You can reach us. We chat a little bit in the KubeCF dev channel, among others. So if you prefer to reach out over Slack, go ahead and do that. That'd be great to hear from people. All right, thank you. Thanks for the questions. Thanks for listening.